Hello, this is an introduction to 4.1. 4.1 is all about angles, and what we're going to be looking at are positive and negative angles first. We're going to be looking at all of these angles in what we call standard form, meaning these angles are going to start on the positive x-axis, and then they're going to end in some quadrant somewhere. So we say that the initial side of an angle is going to be the starting position. So that's going to be the initial side is the starting position. And the terminal side, well, terminal means to end, so the terminal side is the ending position. And you can see the first example here. You can see our initial side, which is our starting position here, and the angle goes counterclockwise, and we have the terminal side. We're going to call this angle theta. That's theta. That's how we're going to reference a lot of our angles in this unit. Now, when we're looking at our coordinate plane, we're going to start talking about degrees as far as our angle measures, very similar to how we did in the geometry unit. We know that if you start at the initial side, and if the terminal side were to go up to this positive y-axis, this would go up to 90 degrees. If we went down to the end of quadrant 2, we'd have 180 degrees, and down in quadrant after 3, we'd have 270 degrees. And then it would go back up to 360 or 0 at this starting point here. Now, in the second picture you'll see that our angle is now going clockwise. This is in turn going to make a negative angle. Now, when we count our angles when it's going this way, we know that the y-axis going down here, this is going to be negative 90 degrees. And then it goes up to negative 180 degrees, a negative 270 degrees, and then a negative 360 would get us down to that starting point again. So then here's just a couple key bullet points. Angles are measured in units called degrees. They're also measured in something called radians, but we will not be using those here. Angles can be rotated clockwise or counterclockwise. If the rotation is clockwise, which would be like this picture here, the angle is going to be negative. Whereas if the rotation is counterclockwise, the angle is positive. So now what we're going to be doing in example 1 is drawing some angles. And it says be sure to include the directional angle. What that means is include this little one that we see right here, because that tells us which way our angle goes. If you just put the terminal initial side, you don't know if it goes this way or if it's supposed to be a positive value. So let's look at the first one together. So we have 60 degrees. Well, we always want to start on the positive x-axis. This is going to be our starting. So that will be our starting. Now, 60 degrees, we know 60 degrees is going to lie in quadrant 1 because 60 is between 0 and 90 degrees. We're not going to be too precise with this. We're just going to give an approximate location. So we know that 60 degrees is a little more than half, so we're going to say someplace right in there. And then we're going to draw our ends on the arrows. And then we want to include the directional. Since this is a positive 60, we know that this angle is going up. And that's what we would have for the first one. So let's go ahead and let's do the last one together, and then I'll have you fill in the other 3. So the last one is a negative 120. So since it is a negative, we know that it's going to be going clockwise. First thing we want to do is draw our line on the positive x-axis. That's going to be our initial side, and then the terminal side. So we have to go to negative 120 degrees. We know this would be negative 90. We know this is negative 180, so negative 120 would lie in here someplace. So we would include that one someplace in here. And then we would draw the ends on our line. Now the directional arrow, since it's negative, we know this angle has to go this way. The directional arrow is very important. If you forget the directional arrow, you will not get credit because we don't know if you're trying to make it go this way or this way. Now pause the video and fill in the other three. You can see here, since it's positive, we know it's going counterclockwise, 130. Next one is negative, it's going counterclockwise to negative 225. And the last one is a positive, so it goes counterclockwise. And again, we just have to make sure this terminal side is lying in the appropriate quadrant according to the angle measures that we talked about earlier. Okay, the next thing we're going to be talking about is degrees in minutes and seconds. We will do this in class together because this is going to be calculator work. So we'll walk through this one together. So let's skip down to the next thing where we have coterminal angles. This is a vocab word that you want to make sure you are familiar with, coterminal angles. These are going to be angles that have the same terminal and initial sides, meaning you might have a negative angle and a positive that have the same initial and terminal, just depending on which way you draw the directional arrow. These are formed by either adding or subtracting full rotations of 360. So for example, if we know this angle that we can see here is 45 degrees, if we had to find the measure of this angle here, meaning if we wanted to find the coterminal angles, we would have to take 45 degrees plus 360 degrees, and then also take that 45 degrees minus 360 degrees. So then we do 45 plus 360, we'd get 405 degrees. If we do 45 minus 360, we'd get a negative 315 degrees. So the one we see in the picture to the left here, this directional arrow here, this would be representing that negative 315 degrees because it's going clockwise. Now, if we wanted to use this picture to the right, to sketch this angle, again, we'd always start with our initial side on that positive x-axis. Now, 405 degrees. Well, we know one full rotation would be 360 degrees. So if we do 405 minus 360, so if we come down here, this is just some sketch work. So 405 minus 360, we're left with 45. That means that that angle will have its terminating side at 45 degrees. So now to draw this directional arrow, we know that it has to make one full rotation, which would be 360, plus another 45, would give us that 405 degree angle. Okay, so what you're doing in the next one is for each angle measurement below, find the smallest positive and the largest negative. We're going to complete that by doing the same thing we just did, add 360 and subtract. So what I want you to do is pause the video, take each of these and add 360 degrees and subtract 360 degrees. Okay, before I show the answers, I just want to make sure you have it set up correctly. Again, to find the smallest positive, you add 360. So smallest positive, you would add 360 degrees, and then the largest negative, you would subtract 360 degrees. So now once you have it set up correctly, go ahead and calculate. Okay, we have our answers. So go ahead and check yours. Now, again, we call these coterminal angles because if we were to sketch those angle measures like we did in the picture up here, they would have the same initial side and they would both fall in the same quadrant and have the same terminal side. Okay, last page here. Standard position, we already talked about this. Standard position is if the initial side is on the positive x-axis, the vertex is at the origin, we say standard position. Again, this is one of those vocab words you want to make sure you're familiar with. And we said the angle is then classified by the position of the terminal side, meaning where the angle stops or ends. For example, if the terminal side of an angle lies in the second quadrant, we call it a second quadrant angle. If the terminal side coincides with one of the axes, it would be called a quadrantal angle. For example, this would be a first quadrant angle because the terminal side is in the first quadrant. This would be a second quadrantal. This would be third. fourth. This would be considered a third because it's in the third quadrant. And then lastly, this would be a quadrantal angle because it lies on a quadrant. The next example says designate the angles in standard position by the quadrant in which the terminal side lies or as a quadrantal angle. So for example, letter A, 59 degrees. Well, we know 59 degrees would be very similar to this one, which is 60 degrees. So the terminal side of that angle would lie in quadrant 1. So now what I want you to do, pause the video and try letter B, C, and D. You can see that letter B, negative 125 degrees, the terminal side would lie in quadrant 3. We'll come back to letter C, and then letter D, negative 270 degrees, that would lie on one of the axes, therefore it's a quadrantal angle. So let's look at 470 to find out where that one lies. Well, just like we did previously, if we have 470 degrees, if we take away one full rotation, which would be 360 degrees, and we subtract that, we are left with a 110-degree angle, which we know lies in the second quadrant, so we know that a 470-degree angle would also lie in the second quadrant. Okay, the last thing we're doing here is going to be drawing angles in standard position when we know a point that the terminal side passes. So here we have the point negative 4, 5. So first thing we're going to do, like step 1 says, is plot that point. So we have negative 4, 5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. And it says draw a ray from the origin through that point. So we're going to start at the origin, which is right here, and we're going to draw a ray as close as we can through that point. Now it says draw a directional arrow from the positive portion of the x-axis to the drawn ray. Because we know that what we just draw is the terminal side, we know this would be the initial, and we know it's going to be in standard position, so it's going up to that direction. And then we should always plot our point. So go ahead, pause the video, and do the next one. Okay, in the next one, we plot the point 3, 2. So we go to the right 3, down 2, draw our ray, and then I drew the initial side, and then I draw the directional arrow from the positive portion to the ray. All right, well, that's a good intro of 4.1. We will discuss a couple of these ideas in class. If you have any questions on anything that I discussed, please make note of it and be sure to ask them when we see each other in class next. Have a good night.